Before I go into detail on Chapter 4, which deals with mutual funds, I want to introduce you to the concept of averages or means, and then standard deviation, which is the variability about an average number. And I'm at first going to work with exam scores because y'all have familiarity with that, and then I'm going to move to stock returns, which y'all are perhaps less familiar with. So what I did is I went back over the past year and I pulled my students' exam scores for the first test in Finance 216, and I have had 130 students take exam 1 last year, and to keep everyone anonymous, I just called them person 1 through person 130, but here are their scores after the curve. And these are pretty meaningless if I look at each 130. That's a lot of data to have to absorb. So what I'd rather do is come up with some sample or summary numbers to represent how the students did. And so the first thing I did was generate a histogram, and you may have been exposed to histograms in high school. I'm not sure, or if you've had a stat class, you have certainly been exposed to a histogram. But what a histogram does is groups all these scores by bins or categories. So I got to choose the bins they were put in. So basically I said group them by tens. So tell me the number of students who earned a score from 0 to 10%. Well, no student earned that score. How many students earned a score from 11% to 20%? Nobody. Nobody from 21 to 30%. One person earned somewhere in the range of 31 to 40%. Two people from 41 to 50%. 14 from 51 to 60%. 24 students earned from 61 to 70%, but you see the bulk of the students fell in this bin, and they earned between 70, actually over 70. I've been saying 61 and 51, but it's really 50.01. But 46 students earned somewhere in the range of over 70 to 80 or less. And then 21 students earned from over 80 to 90 or less. 19 from over 90 to 100 or less. And because this is after the curve, and in my class what I do is calculate the average and then add enough points to get the average up to a 75 if it's less than 75. So let's say the average is 60. I would add 15 points to everybody's score. Well, if you already had, let's say, I don't know, a 95, when you add 15 points to that, that's going to get you over 100. So 3 people managed to earn scores higher than 100. And so when I sum all of these numbers, I get my 130 students. When you graph this, it produces this histogram. And this histogram has the shape of what we call a normal distribution. It has a high point here in the middle. Now that's not necessarily the middle value, 50% out of 100, but it has a high point in the middle of the histogram, because remember all these are empty. And if I were to draw like a curve that represents my histogram, I'd start here, it'd start rising, it'd reach this peak, and then it would slope back down. And it wouldn't be a perfect histogram, but it's pretty close to what we would call a normal distribution. Small values on the tails of either side of the distribution, and the highest value in the middle of the distribution. Because this emulates a normal distribution, there are a variety of things that I can do with it. The first thing that I'm going to do is calculate the mean score, or the average. And y'all have probably been doing this since about the 3rd grade. So I'm just going to average all the values. And when I press enter, what Excel is going to do is sum all the values, all the test scores in column B, and then divide by 130 because that's how many I had. And here is my average. And a lot of times in statistics, when they write that, they'll write it with as an X with the bar over the top. I can't easily put the bar over the top when I'm typing, though. But so if I were to put this average on my histogram, it would fall about right here. But you can see that there's definitely deviation about this average. I mean, this person scored above average, this one below, way above, a little below, below, above, below. So there is variability in these scores about this average or mean. That variability is measured statistically through a number called the standard deviation. I do not need y'all to know how to calculate standard deviation. I'll just provide you with that number. But I do need you to know how to use it once you've got it. So I'm just going to use Excel to calculate my standard deviation. Again, I highlight column B, which goes from cell B2 to B131. And here's my standard deviation. Now, what use are these two numbers to me? To demonstrate that, I need to draw some diagrams and stuff, and I can't easily do that like in Word. So I'm going to be using a drawing pen, and it's not going to look that pretty, but I think it'll suffice. But one thing I might be interested in knowing from looking at these numbers is if on average my grades generally follow a normal distribution, what percentage of the people could I expect to score higher than 90? Now I can actually count them. Okay, I can go through here and count them, but maybe I don't want to do that. It would be time consuming. And maybe I'm trying to predict into the future, like if I've got 1,000 students who take this class over the next 5 years, what proportion of them might I expect to earn scores higher than 90? So I can use this information to figure that out. And I'm just going to jot this down because I don't want to keep going back and forth between Excel and the writing that I'm going to be doing. So I'm going to just round this to 70.8 and to 13.17. Oops. There we go. And here's hoping my drawings look okay. So here's the general shape of a normal distribution. And what we do is write the mean in the middle, and we write it as x bar. And that number is 75.8. And I know my standard deviation was 13.17. Boy, that's an ugly 3, but I don't know if I can make it any better. And I am interested in knowing what proportion of my students earn way over here, 90% or better. So I would like to know this area under the curve. Because this is a normal distribution, it follows very predictable traits. And they have tables where I can look up what percentage falls in the shaded area, for example. Well, I know that from, I don't want my graph to get too busy, so I'm just going to try to write as little as possible. But essentially I know from here to here is half. So 50% of the numbers have to fall on this half, and 50% have to fall on this half. trying to think of a good way to explain things. So the values that I'm interested in finding don't actually, fall. I'm not interested in finding this half. If I were to ask what percentage of my students are likely to earn higher than 75.8 from here all the way to the right, then that answer is 50% because it's exactly half of my normal distribution. But that's not what I'm interested in knowing. This little black shaded area is what I'm interested in knowing. What I can do is, using a table called a Z table, I can look up the proportion of students that will fall in this little area. Let me see if I can easily change my pen color. So I'm shading this area yellow. If I know the area or the proportion that fall in this yellow area, I can fairly easily calculate the proportion that falls in this black shaded area because I know the value of the yellow plus the black shaded area is exactly half or 50%. So if I take, I'll do some, actually I'll do it in blue. So if I take 50% because that's half, I'm trying to write percent, but I'm just having a little trouble. 50% because that's half, and I subtract the yellow portion, hopefully that shows up okay, then my answer will give me the black portion. So how do I find the yellow portion with that Z table? First I have to calculate what's called a Z-score. To calculate the Z-score, you take your desired number and subtract your mean, your X bar, and then you divide it by your standard deviation. In this case, my desired number is 90. Obviously, I need a lot more practice with this writing tool. The X bar is the 75.8, and then the standard deviation is that 13.17. So I'm just going to crunch this fairly quickly. Pop this over here. So 90 minus 75.8 is 14.2, and then divide that by 13.17 gives me 1.08. I'm only going to round to 2 decimals, and you'll see why in a moment. So 1.08 is my Z-score. Then I take this number and I look it up on the Z table. I will provide you with a link to the Z table. I have it here. And the Z table, they kind of did a stylized little graph. And I'm going to draw it ever so slightly better, hopefully. So here's their little, actually I'll just shade it in. What they're really drawing is this. Man, I did a pretty good job with that. So here's their normal distribution. Didn't do a good job with that line. And here is the area under the distribution or the curve that the Z value is telling you. So I sure hope this does not erase all the stuff I wrote on the other tab. Oh good, it didn't. So my Z value is 1.08. So the area that's shaded right here, to find the proportion of it, I go down to 1.0 in this column, and then I go across to 8, so that's going to give me 1.08. So find where this row, I can use this highlighter in theory, so find where this row and this column intersect, and that answer is going to be the value under the normal distribution. So right here is where those two intersect. So this is 35.99%. This black area, though, isn't what I'm after. What I'm really after is, and I'm using different colors than I did before, what I'm really after is this red area, or the area I had actually shaded black on the other tab. So 35.99 is this black area, but I want the red area. To find the red area, I take 50%, subtract the 35.99%, which I'm just going to round to 36 because it's close enough. And so that's going to give me 14% as my answer. So approximately 14% of my students will earn 90 or better on exam 1. At least if in the future exam 1 scores follow a normal distribution. Now I might also be interested in knowing what percentage of my students score 60 or below. So that would fall to the left of the mean of 75.8. So this time I'm interested in this black shaded area. Now, the yellow shaded area and the area that I'm highlighting right now with my cursor are identical. Since this is a symmetrical curve, I could basically fold it in half on this dotted line, and the two halves would overlap perfectly. So the yellow shaded area and the unshaded area directly to the left of the yellow have identical proportion values or percentage values. So if I know the value of this yellow, oh, you know, I didn't phrase that quite right, but I guess it's good enough. So if I know this yellow shaded area, then I also know this unshaded area, and then I can calculate this green shaded area to the left. But I need to use a value of 60 here, not 90. Oh no, that's wrong. Here's what I need to do. I need to calculate my z-score. Remember, I wasn't really working with the value of 90 ultimately. I was working with the value of 1.08. And what that really meant was so here's my x bar. What I really was finding here was what proportion of my normal distribution lies between the mean and 1.08 standard deviations to the right of the mean. That's what I was really finding. But now, with a 60 as my desired number, I would go 60 minus 75.8, the mean, divided by 13.17, the standard deviation. So a quick calculation on that, 60 minus 75.8 divided by 13.17. Hopefully I pushed everything correctly. That gives me minus 0.1997, but I'm just going to round to 2 decimal places because my z-table only goes out to 2 decimal places. So I'm going to round that to minus 1.2. 1.20, but I don't really need that 0. So, so now when I go to my z table, here's my mean, 1.2, positive, but actually let me first pop to my z table and hope it works. Okay, if you look at the z table, you'll notice there are no negative z numbers over here. So that's problematic because I got a negative z number over here. But because my z table or my distribution is normal, if I know this black shaded area, it will equal this yellow shaded area because it's a symmetrical distribution. And if I know this yellow shaded area, then I can calculate this orange shaded area, which is the area that I truly want to know. It's going to represent the percentage of my students that earn less than 60%. Why do I have to do it all this way? Because the z table that I'm going to provide you only tells you the black shaded proportion. Therefore, you have to calculate the rest. So let's go find the area under the distribution that's shaded black. So I have to look up a z-value of 1.2, even though I got a negative 1.2 when I crunched this down here. So my 1.2 is what I'm after. So go down this leftmost column, find 1.2, and then go across to 0 because it was 1.20, and I find this number, 0.3849. So 38.49% was the value of this black area. So it's also the value of this gray area. So to find the value of the orange area, I take 50% because 50% is half of my distribution. And then I'll subtract the 38.49. And that's going to give me what? 11.01%. So the percentage of my students that earn 60% or less on the first exam is 11.01%.